Vaccines have assisted man in the battle against disease for more than 200 years. Due to the latest developments in immunology and biotechnology, it has now even become possible to consider the creation of vaccines against illnesses as threatening as cancer. The surface of a cell is covered in a number of different proteins. Certain proteins, however, are exclusively found on the surface of cancer cells. These proteins are referred to as tumor markers. Tumor markers function as receptors, and when binding with ligands, create a signal stimulating unlimited cell division and tumor growth. It is believed that successful anti-cancer drugs will be those which prevent cancer cell receptors from interacting with ligands, thereby blocking the signal for unlimited cell division and tumor growth. Academic literature gives descriptions of anti-cancer vaccines capable of evoking an immune response to tumor markers. Generally speaking, these vaccines work in the following manner. Once the immune system has become fortified against the agent, specific proteins are developed in the body called antibodies. Antibodies bind with tumor markers located on the surface of the cancer cell, enabling the immune system to identify and destroy them. The antibodies which are created in response to the vaccine remain in the body for several years and are capable of having both a prophylactic and a therapeutic effect. However, one of the weaknesses of vaccines produced to date is their low selectivity capacity. This means that the antibody is not always successful in blocking the specific part of the protein receptor that binds with the ligand, and as a result, the cancer cell continues to receive the signal for unlimited division and, as a result, tumor growth. Another promising approach in the battle against malignant tumors is the use of monoclonal antibodies, which are produced using biotechnology techniques. In the human body, monoclonal antibodies link with the most significant parts of the receptors located on the surface of the cancer cell, thereby blocking the signal for unlimited cell division. Nonetheless, medicines based on monoclonal antibodies also have their drawbacks. For example, in order to achieve a therapeutic effect, a permanent level of concentration has to be maintained. This is achieved by injecting antibodies intravenously every 2 to 3 weeks over a number of years. Unfortunately, this type of drug is not capable of preventing a relapse. In other words, it does not have a prophylactic effect. In addition, monoclonal antibodies are foreign proteins which can cause serious side effects. It is believed that one of the most promising new generation anti-cancer drugs is the so-called peptide vaccine, which combines the best qualities of both classical vaccines and monoclonal antibodies. The main component of the peptide anti-cancer vaccine consists of fragments of the tumor markers which are essential to the development of a tumor. For example, fragments of cancer cell receptors that facilitate binding with ligands. These fragments are chemically synthesized and fixed to the surface of dedicated carriers. Peptide vaccines generate narrow specificity antibodies on those parts of the target protein that are responsible for transmitting the signal for cell division and tumor growth. At the same time, the antibodies mark the cancer cells, making them vulnerable to attack by the cells of the immune system. In this way, tumor growth is prevented, and at the same time, existing tumor cells are destroyed. The antibodies that are created in response to the vaccine remain in the human body for several years. and have a therapeutic as well as a prophylactic effect. Over the past few years, Epitec has been developing an anti-cancer peptide vaccine. Laboratory vaccine models have already proved effective on animals and tumour cell cultures.